Hola a todos en Latinoamérica y bienvenidos al Flisol 2021 que se desarrolla en línea gracias a los amigos de Flisol de más de 17 países aproximadamente que están conectados en simultáneo para escuchar estas charlas y talleres que se han desarrollado para toda Latinoamérica y para todas las personas que están interesadas en este mundo tan especial que es el software libre. Agradecemos la presencia del día de hoy de Jon Maddog, es el presidente ejecutivo de Linux Professional Institute, quien brindará unas palabras referente al poder del software libre. Agradecemos a todos los organizadores de todos los países con quienes venimos trabajando desde hace casi 2 meses para que este sea un evento que satisfaga todas las expectativas de ustedes. Muy bien, cuando gusten, por favor, escuchamos a Jon.
Hello, everybody. It's nice to be here. We've recorded my talk with Spanish and Portuguese subtitles so that people could listen to them, and for that matter, English subtitles. So I think we're going to show the video first, and then we'll have a question and answer session afterwards to answer your questions. Hello, my name is Jon Maddog Hall, and I'm the board chair of the Linux Professional Institute and the president of Linux International. Our talk today is called The Power of FLOSS, or Free and Libre Open Source Software. For those of you who don't know me, I've been in the computer industry for over 50 years. I've had a wide variety of different jobs, from a programmer to systems administrator, product manager, and all sorts of other things. I want to tell you this to let you know that I've been around a while and I happen to know a few things about free software and computers. First, we're going to talk about what is intellectual property. Intellectual property is a concept of a person's ideas and the ideas that they come up with. And it's covered by 3 main points in U.S. law. I'm going to talk about U.S. law because that's the one I know the most about. However, U.S. law has been reflected in a series of other laws in other countries around the world. It may not be exactly the same, but it's close. So, copyright, patents, and trademarks are the 3 things we're going to be talking about. Now, any of this intellectual property really didn't apply to computer software for the very beginning of computers around 1945 to about the 1980s. No copyright or patents could be applied to software. They could be applied to hardware, they could be applied to many other things, but not to software. Software, if it needed protection, legal protection, was protected through contract law. The purchaser of the software would get together with the seller of the software. They would determine how much it would cost. They would determine how it, what was going to be done with it, how many computers could go on it, how many people could use it at one time, and so forth. This is because a lot of the software was incredibly expensive. You might pay $100,000 US for a commercial compiler, as an instance. And so people would program, would get together with their lawyers and argue about this for a long time. Once a contract was signed, then it's possible that the buyer of the software would actually be able to get the source code for the software and put it into escrow. Give it to a lawyer to protect in case the company that sold the software would go out of business. And the people who bought the software, who had purchased the software, would then be able to get access to the source code and fix the software themselves. There was also software that was distributed through user groups like DECUS. That was from Digital Equipment Corporation, or Share from IBM, or a series of others. These were users who wrote the software for their own use, but then said, hey, I'm not in the business of writing software. I'm not in the business of selling software. I am going to donate my software to these user groups. They can put them into catalogs. They can distribute the catalogs to people. People can order the software purchased on perhaps paper tape or magnetic tape, and they can have access to my software. I don't guarantee that the software is going to work. I'm not going to fix bugs for them or anything. It's just something I'm going to do because I've got the software for my own use. I'm going to let somebody else use it. There are also online bulletin boards where a person could dial up with a modem and get software from those. Sometimes they were binary-only form, sometimes they were in source code form. Most often they were in source code form because there was not one standard operating system or one standard architecture. So the programs would be written in something like BASIC, or they might be written in assembly language or machine language for a particular piece of hardware. But they typically were not for any particular operating system because the personal computers of those days were too small and too weak to really support an operating system. There was also magazine articles that perhaps they would publish a game or publish a piece of work like an editor or something, and you could type the information in from the magazine article into your computer, either assemble it or compile it and have it work. And these were the ways that a lot of software was distributed in those days. About 1980s, people started to create computer games. Computers were cheap enough, and people would put together little game boards, of a CPU and some RAM and an I/O card or something like that, and they would sell them. And companies like Atari and other companies came into being. And what would happen is these companies would make one game board, sell it to some people, and people would then duplicate the game board and then copy the ROM that had the game in it. And of course, the companies like Atari didn't like this. So they went to the U.S. government and said, we want to copyright the ones and zeros in those ROMs so that people cannot simply copy the ROM from one place to the other. That would be illegal. And the government looked at that and said, you're right, you should be able to get a copyright on that. And they did. And the copyright was automatic for that. As soon as you created those ones and zeros, you owned that copyrighted material. And you could also register that copyrighted material that would give you even greater protection and have even greater fines if people were found to be doing it illegal, copying it illegally. Now, after that, after you have the copyright, you really need to have a license because a copyright says you own that particular piece of information. The license then tells other people what they can do with your intellectual property. So the license says, okay, you can copy that ROM and sell it to other people, but if you do, you need to owe me a royalty of some type. Or in effect, it is a contract, but it's a contract between you, the owner, and many people. In addition to that, they had the concept of the end user, the person who's not going to be distributing this to anybody else. However, they should also be protecting it and making sure that nobody else can get this copyrighted material without paying some type of royalty or copyright fee. And that is the EULA, or the End User License Agreement. Now, this also created a situation where when you bought software, you thought I'm buying software. You weren't really buying the software. You were buying the right to use the software, a particular version of it, and typically for a particular time. You could not, if you sold a computer, you could not sell the software that went along with it. You would have to take and wipe out all the software on that computer because as an end user, you could not transfer your right to use that software to anybody else, even if you sold them the entire system. They would have to then get a fresh copy of that software, have a fresh EULA for them, and be able to then use the software on that computer, a used computer. Now, along with this came the concept of licensing the source code. The source code, of course, is the code that you write as a programmer that is then transferred into the ones and zeros the computer can understand. And most people are familiar with closed source. This code is written by companies like Microsoft or Oracle. They write the code, they create the ones and zeros, and then they distribute the ones and zeros to other people. And in this type of code, typically the owner has all of the rights, the right to change it, the right to know how it works, the right to make multiple copies. They own all of the rights, and they give the end user some little portion of those rights, the right to use the binaries to do whatever they want. Now, you have to take a look, and if you look back in time, it used to be that most code was open source, that people wrote the source code and they didn't care if you changed it or anything else. In fact, if you changed it, they'd love you to have you give them back the changes. That would be great. But when people started to get the closed source, some people started to become upset about this, and they said, well, I wanted to get the source code for this binary I have, and I want to be able to make changes to it. I want to fix bugs. I want to be able to make extensions to it and things like that. And so the owners of the code, the people that own the copyright, said, well, okay, we'll do that. We'll create a license for you so that you can change the code, but under specific circumstances. So, maybe you have to give us attribution. You have to say that the original code came from MIT or came from Berkeley or came from some other company or some other organization. That is attribution. Maybe you have to say, well, you can't call your code. If you change it, you can't call your code the same thing as I called my code. You're allowed to call something else, maybe with attribution, maybe not. But, you cannot call your code, for example, Perl. Now, it may have started out as Perl. I may have given you the source code for Perl, but you changed it. And unless I accept those changes back, you cannot call your changed code Perl. And of course, if I accept those changes back, then in effect, your Perl and my Perl are the same Perl. This is known as an artistic license, and it's typically used in compilers or languages or things like that. And these different licenses give different rights to different developers. Open source is really good for developers. It allows the developers to start with a body of code that they can improve, they can make changes to, they can compile, they can support, they can document, and they can sell it to the end user. However, it doesn't really give the end users a lot of rights, because it's possible that they receive only the binary code. They don't receive the commercial code, the source code. So there is one open source license which we call free software. And the difference between open source and free software is that with free software, you have to give the source code changes to the end user. And almost the same thing, those end user changes have to be made available to the people who made the code in the first place. So when it's sent up to the people who made the code in the first place, we call that upstreaming. When we give it to the end user, that's called downstreaming. And so free software, as represented by the GPL, the General Public License, also sometimes called copyleft instead of copyright, has basically 4 freedoms. In the beginning, it only had 3 freedoms. The first freedom was the freedom to see the source code for the binaries you're using. The second freedom was to study that code and to learn from it and to see how it worked. The third freedom was to distribute modified versions of that code to anybody who wanted them. Now, maybe you didn't modify the code at all. You're just distributing the original. That's okay too. You had that freedom to do that. And those free freedoms went on for a couple of years, and then people realized that there was another freedom that was missing. Because there were a lot of people who were writing GPL code that said, well, I don't want my code to be used by banks because I don't like banks. I don't want my code being used by the government because I don't like the government. I don't want my code being used by the military because I don't like the military. And by the time you put all of those together in your little Venn diagrams, you find out that nobody's code can be used by anybody. And so the zeroth license came out, the freedom to use code for any purpose whatsoever. Even if it's a horrible purpose, you still have to have the freedom to use the code for that. You cannot legislate morality through technology. If you want people to be moral, then you convince them to be moral, and then they use your code in a moral way. And so these are now the 4 freedoms of the general public license, the GPL. Let's stop talking about software for a little bit, and let's talk about open hardware. Same type of thing can happen, that the hardware starts off simple, it starts getting more complex and more complex, and people would like to be able to see how the hardware works so that they can keep improving it in incremental improvement. But in addition to that, they also want to see how the hardware works so that they can write software for it that works better. A prime example of this is in graphical processing units known as GPUs. A lot of times the GPUs are not fully open. They do not show all the documentation on how to program them. Some of the programming may be hidden in the device drivers and things like that, which are binary only. And this creates problems in maintaining it. It creates problems in getting the best performance out of it, and so forth. So people want to see open hardware. They want to know as much as possible about how the hardware is created so that they can give better support to it over a longer period of time. Now, when it comes to manufacturing some type of circuit board, you might say, okay, we use these components. This is known as the bill of materials, or BOM. And if the components are complex, like a CPU or a GPU, we want to have a data sheet that says exactly how that CPU or GPU is programmed. We also want to know how these pieces are laid out on the printed circuit board, because all of this can affect the way that the system works. It may not be that we get every single piece of data that we would like to get. A particular version of this is called Gerbers, which are the files that drive the surface mount technology machines that make the printed circuit board. But a Gerber would change according to what machine you were using, and there's lots of other reasons for the Gerber to change. So it may be open enough to have all of the other things that you come in a piece of hardware without having something like the Gerbers, which are very specific to a specific manufacturing line. So open hardware has different definitions. You have to really look at the person who's putting out the hardware design as to how open their hardware is or is not. Now, examples of closed hardware might be Apple versus the PC, or Intel versus ARM versus RISC-V, which is a new architecture. So let's take a look at Apple versus the PC. In Apple, they tend to make all of the hardware, they make all of the operating system software, and they do what they call a stack. And this allows them to know exactly how the hardware works, and the operating system knows exactly how the hardware works, and they can gather all sorts of error messages and things like that to create a very stable, very efficient system. PCs, represented by Microsoft and typically Intel and things like that, went in a different direction. They said we want to have as many hardware vendors as possible, making as many different types of hardware, and we're just going to make the operating system that goes on top of that. So this allows a lot of innovation in different styles of hardware, and also creates competition with prices and things like that to create a whole ecosystem. Now, if you take a look at what was happening with Apple and Microsoft in the, let's say, 1980s, Apple might own 7% of the desktop market. And it was a very profitable 7%. People really loved their products and things like that, but it was only 7%. Microsoft owned about 90% of the desktop market. But when I say owned it, they owned the software side of it. They owned the services side. And the hardware side was owned by Dell, IBM, all these other different companies that shared in that. But there was a much greater number of Microsoft, what we called Wintel systems out there than Apple. The same type of thing might be said for iOS versus Android. iOS was developed by Apple. It goes on Apple phones. You can't see iOS on many other people's phones. It's only Apple's phones. Android goes on many different types of phones. It is even imported to some Apple phones. And therefore you have a much greater penetration of Android into the phone marketplace. If we want to take a look at CPUs, Intel is designed by Intel, is manufactured by Intel in Intel fabrication plants. Compare that to ARM, which designs the architecture and creates the architecture, but it can be manufactured by many different manufacturers, Samsung or all these different what we call fabrication plants. And this allows people to make changes to the architecture that extend the architecture without having to get ARM involved in that. RISC-V is an even newer architecture. It is an open architecture. It allows people to extend various parts of it. It creates a base of the architecture, but then there's many, many different ways to improve it without changing the architecture itself. So RISC-V is looked at as being the most open of the hardware architectures. ARM is next, and Intel is looked at being most closed. We also should talk about open culture, because up until now we talk about software and hardware, but what about art? What about music? What about books? Those are also cultures that can be closed or open. And one of the first things that was copyrighted of all time were books. Before the Gutenberg printing press, you didn't need copyrights on books because books were copied by scribes. It was a very slow, very painful process done by the scribes, and people didn't, make thousands of them. They were typically for kings and priests and very well-educated people, and made books incredibly expensive. Most people could not read. They only needed to read if they became a public servant or something like that. But when Gutenberg made the printing press, then what happened is somebody would write a book, they'd take it to a printer, they would have it set, they'd print maybe 100 copies and start to sell it. Some other person would come along, get the one copy by one copy, take it to another printer, have it set, and start printing the same book, but by a different printer. And therefore the first person would not make any money off of their book sales. So copyright prevented this from happening. It said, I'm going to write the book, I'm going to print the book, and if somebody else wants to print the book, well, they can license it from me, and they can charge for the actual printing itself, but they can't charge for the intellectual property. That intellectual property has to be given to me. And there were There were limits put on this as far as time, so many years, the copyright had to be given up, and so forth and so on. So the problem came with this is what happens if the original copyright holder dies? What happens if you see a picture and you really like it, you say, oh, I'd really like to have a copy of that picture, but I can't because it's copyrighted. And so you have to go back to find the person who owns the picture. You have to say, can I make a copy of your picture? Can I use your picture? And they would say, well, yeah, you can, but it's a big pain in the butt. I have to make the license for you and everything. I'm not going to charge you anything for the picture. So, just go ahead and use it. But you would want to have some type of guarantee that they wouldn't change their mind, that they wouldn't sue you later on and things like that. So the idea of Creative Commons came about, of a very simple symbol or way of licensing it with very specific details to the license that can be done very simply. If you look at the bottom of this slide, and every slide I have, there's a little symbol which talks about the Creative Commons license. Yes, you can make a copy of these slides, but you cannot make a derivative of them. You can't change the content on the slides. You can't say that, you can't change what I have said. You have to attribute it to me. I want to have the right of attribution. And this also helps if somebody else wants to contact me later and find out that, can I change the license? Can I change the slides? Whether it's commercial or non-commercial. In this particular case, it is non-commercial. You can give this away. You have to give this away. You can't charge for it. But if you wanted to charge for it, then you have to see me for a different license. And so that little symbol has very specific meanings, legal meanings in a court of law about culture. And you could do that with pictures, you could do that with books, you could do that with any type of culture. Now, there's a final piece of, in effect, non-intellectual property I wanted to talk about, and that's public domain. Public domain, when you put your item in the public domain, you say anybody can do anything they want to with it. They can change it, they can give it away, they can sell it, they can make a binary-only copy and sell that. It's really a terrible idea to put your thing in the public domain. And the reason for that is that you lose all control over it. And you have no right to say whatever happens to it in the future. So it's much better to allow your copyright to go on and pick a suitable open source or free software license to go with it, or use Creative Commons or some type of thing like that to protect the little rights that you want to have. A second idea I want to talk about is called dual licensing. Now, let's say you've written some software, and we'll use MySQL as an example. It's a database, and you want to make it free software. You want to be able to license it as GPL. And so people will make changes to it. They'll give away their changes. They have to make their source code available to the end users. Everything is fine. But you have a customer who says, I do not want to do that. I do not want to give away my changes. I want to I want to sell them. I want to have a binary only copy. And, so they would come back to you and you say, okay, if you're going to give it away, you have to give it away with GPL. If you want to sell it, I can give you a different license. I can give you an MIT license or a BSD. I can give you an open source license. And you can then make your binaries and sell them if you want to. And this is known as dual licensing. And in reality, it could be multiple licensing. You can have lots of different licenses applied to the same code. Now, you have to do this if you are the only person who owns the copyright to that. So let's say you have a big project and a lot of people contributing. When they write their code into your project, they have the copyright over the stuff that they have written. And, so you would have to have different licenses or the same license, and everybody would have to agree to the same license. The problem with that comes when one person dies or they get mad at you and they leave the project, and now you want to change the license. Well, they have to give their permission for their copyrighted code, and that's a problem. So what happened with GNU is the GNU project, everybody that contributes to the GNU project assigns their copyright to one person. That one person owns all the copyrights of the code, no matter who wrote it. In the Linux kernel, it doesn't happen that way. Linus Torvalds never got everybody to assign their copyrights to him, and therefore it is stuck on a GPL 2.6 either for all of time or up until the point where somebody rewrites all of the code in the kernel so it's under one copyright. What are the advantages of free software? Well, one advantage of free software is protection from obsolescence. It may be that the company that wrote your software got tired of it or went out of business or whatever, and from the time they stopped that, your software is getting older and older. Maybe there are bugs that are found in it, maybe there are security holes, maybe it has to be put into a new version of the operating system, maybe you would have put it on new hardware. You can't do any of this because you don't have the source code for the software that you bought. Another advantage of free software is to create local skills and jobs in writing complex software. This could keep money inside of the borders of your country. Instead of sending your money to Redmond, Washington, or sending your money to Silicon Valley, it keeps the money inside of the borders of your country, paying local programmers who then use that money to buy local food, local housing, and pay local taxes. This turns over that the people they're paying all this money to can therefore buy more software. It also creates less of a brain drain of people leaving your country because they get good jobs to work on, they get good things to do, and they don't go to your universities, get a free education, and then decide to go to the United States or go to Europe or go to China to be able to do their work. So it tends to create a good job inside of your country to allow people to stay there and move your country forward. And this also allows you to attract new research, new development, and new manufacturing to your country. If all of your best programmers and your best people leave your country and go these other places, then when these companies who want to do new research, development, and manufacturing, when they start to look at your country, they'll say, oh, I'm sorry, you don't have enough of the best people in your country to do that, so we're not going to come. It also allows you to tailor the software to your needs. Maybe the software was originally written so that all of the prompting was in English, but you speak German. Without the source code, you may not be able to tailor the English prompting in your program to be German. It may mean faster mean time to repair. Now, a lot of people say, what is more secure, closed software or free software? And without going into a lot of detail, I can tell you that it's just about equal with both. I mean, you can have really secure free software, you can have really secure closed source software. But the difference comes when you find the bug, when you find the issue. How fast can you get a repair on that? Now, for example, if you found a security problem with Windows XP, your mean time to repair is almost infinite because Microsoft says we're just not going to repair it. We're not going to fix those bugs. If you found a security bug in free software, even if the developer said, hey, we're too busy to repair it right now or whatever, you have access to the source code. You could hire somebody to fix that problem and get it repaired very quickly. Another advantage of free software is better national security. And this comes from two areas. Number one, if all you get is closed source software, you can't look into it to see if there are trapdoors and malware and other types of things in the software. With free software, you can see that. Now, there are some companies that say, oh, well, we'll set up a way that you can look at the software and you can see that there's trapdoors in it or malware in it or not. And we're going to let you look over the internet into our source code pool to see that. But the problem with that method is the fact that there's no guarantee that the source code that you're looking at in that software pool is actually the source code that created the binaries that you're using. And sometimes the trapdoors and malware are not created by the source code itself, but by bugs in the compilers or in the libraries or whatever else that's in the ecosystem. So you need to have control of not only the software that created the binaries that you're looking at, but the processes and procedures of taking that source code and making the binaries and making the system that you're using. Another advantage of free software is it helps to protect you from shortages from embargoes. I come from the United States. We've had an embargo against Cuba for the past 60 years, so long that most of the people in the United States have even forgotten what the embargo was about. We've had embargoes against Iran. We've had embargoes against a lot of other countries where we say we cannot share certain technological things with these countries. Well, the United States is a very big and powerful country, but what if it was your country that was on the other end of that embargo? How can you take something that's so critical to your country, like software and hardware, how can you take that and allow other people to control that, have it be outside of your control? And so, you have to have something to make sure that you can have access to the source code if you need it, you can have access to the hardware you need it. And that means that you should be doing as much as you can to create that software inside of your own country. Free software allows you to reach out across the net, pull the software into your country, and then change it utilizing people in your country that you trust, that are your loyal citizens. Another thing that's an advantage of free software is a faster startup of new businesses. Back when I started in computers, if you wanted to write a computer program, you needed to write your own input software, and you needed to write your own printing software and things like that. But then people started to create relational databases and object databases, but they were very expensive. And so you had a trade-off of either writing your own or using this extremely expensive software to create your prototype, to create your new solution for your customer. You can now use free and open source software to do this. You can say, I'll use MySQL, or I'll use PostgreSDB, or I'll use some other database system for that. And you can create your own either prototype or even a final solution using mostly free and open source software. Because the customer doesn't really buy hardware anymore. The customer really doesn't buy software anymore. What the customer is really buying is a solution to their problem, and they really don't care whether that is a closed source solution or an open source solution, other than they want it to be secure, they want it to have a life, they want it to be maintainable, and so forth, and they would like to give some type of money and support to people in their own country as opposed to other countries. So, in summary, closed source is only one model of software development. There are many other models of software development, just like there's many economic models, not just capitalism, but there's socialism and other types of economic models. So you can choose the software development model that you want. FLOSS can reduce the costs and create better solutions for people. Because when you have two closed source solutions and you're trying to get them to work together, sometimes it's like trying to glue two glass rods together with glue. They're so smooth that they don't really work together. But if you rough them up with sandpaper and then apply the glue, then they will stick together better. So if you can change the two pieces of software that you're trying to combine to work together, then you can typically get a better solution than if you can't. And floss is better for your economy. It moves the money, the money that's paid for the creative things that you're doing into your own economy instead of sending it out to places like the United States or Russia or China or Europe. It's better for the end user because the end user now has control over their software, over their hardware, and over their solution. So with that, I will try and answer any questions, and I thank you very much for listening.
Hello, my name is Jon Hall. I'm the board chair for the Linux Professional Institute and the president of Linux International. Our talk today is about free and open source software for developers and managers. For those of you who don't
Maddog, I
Yes.
will ask you the questions in English for you, of course, and then as I will do the sequential translation, I'll ask you to give me the usual pause for me to translate.
Okay.
I will start with one question that people are already debating here in the comments in YouTube. This is by Giancarlo Triana Guzman. Is there any reason to use closed software instead of the free software? Because I don't know about this topic, but all I hear it's free software is better than closed software. So, is there a special reason why people still would need to use closed source software?
I really cannot think
I'm
of
not
any
hearing
reason.
you. You're mute.
No, I'm not. No, I'm not mute.
Oh,
Um,
1
Yo
second.
lo
Let me
escucho.
see.
It's
Okay, now I
okay.
hear you. It was on my side.
aha. I cannot think of any reason why somebody would want to use closed source software. In the beginning, as I said, all the software was open source. And the only reason, okay, the developers, the people who developed the software, started creating closed source in order to protect their source code. So instead of these companies relying on things like a license or terms in a license, they decided to only distribute their software in binary only form to the end users. But from the customer's standpoint, there's absolutely no reason why a company should not use a free and open source license. I hope I answered the question.
En inglés.
Well, actually, it can be a very short answer. It really, when the kernel of the operating system basically controls the hardware and schedules tasks. And so, if you have a very simple kernel that only controls one program at a time, like as in a real-time system, or a very simple kernel, then you could write it in a very short period of time. But the more things you ask the kernel to do, such as control thousands of tasks, or hundreds of different threads inside of the CPU, then it becomes more complicated. So, for example, I recommend to people, if they're studying um, computer kernel design, that they start with a very simple kernel such as FreeDOS. Do you have any more questions?
César, solo quiero avisar que en la transmisión en YouTube vos no estás apareciendo. Entonces tus preguntas no están siendo escuchadas y tampoco las traducciones.
If someone is speaking, I can't hear them.
Cortázar, si está por ahí.
Hernán, ¿puedes avanzar tú con las preguntas?
Hernán, pues tenemos un pequeño problema con Hernán, no le estamos escuchando. Recarga la pantalla de OBS, por favor, Hernán.
Están ustedes porque estamos ahorita en conferencia con CPSH.
¿Me pueden escuchar? César, Hernán.
YouTube entró Hernán nuevamente, pero yo no...
Ya, ahora sí ya estás en vivo. Puedes continuar.
Yo tengo una pregunta que aquí me hace Hernán, o sea, mientras tanto vamos a... Entonces, la siguiente pregunta es que le hacen a Jon Maddog es ¿qué distribución de GNU Linux usa en su computadora? Y desea recibir información del LPI para el futuro, ¿qué debe hacer? Lo pregunta Rodrigo Castón desde el país Argentina. Entonces, esa es la pregunta para Jon.
César, ya estás en vivo. Puedes probar nuevamente.
Sí, puedo. Vamos a intentar entonces nuevamente. Les pido disculpas a los que no escucharon las respuestas a sus preguntas. Yo estaba aquí hablando y hablando y hablando, pero ustedes no estaban me viendo. Bueno, la pregunta ahora es una pregunta clásica para Mad Dog, ¿no? Entonces, como ya la pregunta ya está hecha, voy a traducirla para el inglés. Mad Dog, the classic question now that you have to answer probably in all of your presentations. What is the distribution that you use?
I do not like,
Que es buena para ellos.
since I am a consultant, I typically use a distribution that my customers use.
Como yo soy un consultor, yo típicamente utilizo las distribuciones que mis clientes utilizan.
Or perhaps I have a particular project that I'm working on that particular distribution supports that hardware or that project.
Y todavía también puede estar participando de un proyecto donde hay un sistema y que ese sistema es soportado por una distribución en particular, entonces voy a utilizar esa distribución.
So I really can't, I really do not like telling people, oh, I use this distribution on my laptop or my desktop because I use a lot of them.
Así no me gusta decir para las personas que utilicen esta o esta otra distribución en mi laptop, porque lo mejor es que las personas decidan cuál es el tipo de distribución que les agrada más, que les sirve mejor.
If people are just starting to use and learn Linux, then I recommend that perhaps they use the distribution that their school uses or that their friends use so that they can get their questions answered more readily.
Y si tú estás empezando a utilizar Linux ahora, lo que te recomiendo es que utilice la distribución que tu escuela está utilizando o entonces que la mayoría de tus amigos están utilizando, porque así puedes obtener el soporte que necesitas de tu grupo, de tu escuela, de una forma mucho más sencilla.
And because most of the distributions are completely free of charge to download, then you can try them out and see which one you like the most.
Y como todas las distribuciones están disponibles de manera sin costo, puedes descargarla por la web. Te recomiendo que experimente con algunas distribuciones que puedas entonces decidir cuál es la mejor para ti.
And there are many discussions on the web about the qualities of each distribution and why it is good or why it is bad.
Y así es mejor que tú mismo decidas por qué una distribución es mejor o esta es peor.
And most of the time, my feeling is that the discussions are only about which distribution is good and which distribution is better.
Y normalmente a mí es divertido recibir esas preguntas, que siempre las recibo. ¿Cuál es la distribución mejor? ¿Cuál es la distribución peor?
If you want a bad distribution, you can try Microsoft Windows.
Si quisieres una distribución muy mala, puedes intentar Microsoft Windows. Muy bien. Déjame ver si tenemos alguna otra pregunta que viene del formulario. Hay aquí una de Diego de Colombia. ¿De qué manera se podría incentivar al uso del software libre en países en vías de desarrollo? La pregunta, the question, Maddog, is how can we incentivize the usage of free software in developing countries?
Part of that is to talk with your government and your schools and to tell them the advantages of using free software in your government and in your schools and then in your businesses.
Es necesario hablar con tu gobierno y decirles la importancia de utilizar el software libre, tanto para las agencias de gobierno como para las instituciones de ensino y también para las empresas.
For example, all of your documents used by the government or used by business should be using the ODF format for distribution.
Por ejemplo, todos los documentos que son generados por el gobierno y que el gobierno hace intercambios con empresas deben estar en un formato abierto, como por ejemplo el formato ODF, que es un formato estándar.
All of your documents should be using free fonts so that people can have ready access to the fonts that go into the documents.
Todas las fuentes para los caracteres utilizados en los documentos también deben ser libres para que puedan ser intercambiadas y fácilmente visualizadas por cualquiera que va a utilizar, va a abrir ese documento.
You may want to convince your government and your business to use a open office package, like, free office package. And that way they produce documents that people can readily use with free office.
Y tú también debes insistir para que tu gobierno utilice paquetes de software libre y abierto para manipular esos documentos. Cualquier pacote libre para el Office.
This alone would save your government and your business millions and millions of dollars a year not being sent to Microsoft.
Solamente haciendo esa cosa muy sencilla, eso te va a economizar millones y millones de dólares que tu gobierno hoy envía directamente para Microsoft.
And instead, they can use that money that would buy Microsoft Office licenses and pay that to local programmers to make the open document better.
Y así, al no enviar ese presupuesto para empresas de otro país como Microsoft, ese presupuesto se queda en tu país y así puedes utilizar para hacer inversiones en la mejoría de las soluciones de software libre, incluso esas soluciones que trabajan con esos documentos libres.
And of course, if you redirect that money to local programmers, it gives them jobs. It keeps them from going to other countries looking for work. And it also means that they buy local food, local housing, and pay local taxes.
Y así esas inversiones que ahora se quedan en el país son utilizadas para pagar los desarrolladores que entonces no van a salir para otros países en busca de otros empleos y además de eso van a gastar su dinero en el país, comprar cosas en el país y pagar impuestos en el país.
That's only one example of how a country could save money by using free software. Another example is instead of buying a commercial closed source database engine like Oracle, you could use Postgres, you could use MySQL absolutely for free.
Y esa cuestión de los pacotes oficinales, de los documentos abiertos, son apenas uno de los puntos por los cuales el gobierno puede economizar dinero. Si pensamos en la utilización de bases de datos privativas como Oracle y la cambiamos por PostgreSQL o MySQL, también podemos economizar mucho más dinero.
You could teach students how to use free software to solve problems, to create solutions for the people in your country.
Tú puedes utilizar en las universidades softwares libres e enseñar a los estudiantes cómo utilizar el software libre para crear soluciones específicas para tu propio país.
So again, instead of sending this money outside of your country to buy solutions for people, you're making money, you're making jobs for people in your country, and you're also increasing their expertise in how to develop good software problem or solutions.
Así, además de mantener el dinero en tu país, tú estás haciendo inversiones en personas que van a se cambiar en expertos y van a ser más capaces de crear más soluciones y además economizar más dinero y mantener ese dinero dentro de tu país.
When you teach a computer student using free software, you teach them 3 times.
Y cuando ensinas a los estudiantes a utilizar software libre, los ensinas 3 veces.
Normally, when you teach a student using closed source software, you teach the student how to use the software to solve a problem.
Cuando vas a ensinar a los estudiantes a utilizar software de código privativo, vas a enseñar el estudiante a cómo utilizar el software para solucionar un problema.
The students cannot see how the software works to solve that problem.
Los estudiantes no van a poder ver cómo el software marcha para resolver este problema.
The students can't work to improve the software to make the problem better.
Si los estudiantes pueden saber cómo el software marcha, pueden mejorarlo para cambiarlo en un software mejor.
But when you use free software to do the same thing, the student learns how to use the software to solve the problem.
Así, si utiliza software libre, además del estudiante poder utilizar el software para resolver un problema,
they can see how the software solved that problem.
Eles también pueden ver cómo el software resolve ese problema.
And they can learn how to improve the software to solve the problem better.
Y también pueden aprender cómo mejorar el software para que el software pueda solucionar a un problema de una manera mucho mejor.
So the student learns 3 times instead of only once.
Así, el estudiante aprende 3 veces, al contrario de apenas aprender una vez con el software privativo. Muy bien. Maddog, hay otra pregunta aquí. Cuando los organizadores piensan que el tiempo para cerrarnos las preguntas, entonces avisamos a los que nos están viendo. Caso contrario, seguimos adelante. Esta es una pregunta. Sí, por favor.
Bueno, tenemos que, desafortunadamente, debemos de informar que hemos hecho una programación en los diferentes canales de YouTube para que las videoconferencias puedan ser grabadas en diferido. Afortunadamente, el tiempo es un factor que no es infinito y pues va a iniciar ya en pocos instantes la siguiente conferencia. Vamos a hacer lo siguiente. Sugiero que las preguntas que se vayan realizando las sigan realizando por el formulario que es lpi.org/flisol. Todos los organizadores en Latinoamérica que las suscriban ahí. Y en este momento, pues, junto con Hernán Pachas, con Chris Brott y junto con Jon Maddog, vamos a estar en el backstage ahí dándoles soluciones a las respuestas. Desafortunadamente, el tiempo, pues, es un recurso muy precioso. Y, pues, por las dificultades técnicas al inicio de la conferencia, del festival, es la siguiente conferencia. Pero pues agradecemos a todos por su atención. Gracias, Hernán, por tu tiempo. Gracias, Chris. Para ir cerrando.
Solamente, Alejandro, agregar nada más. Thank you to Jon for talk in this today. Thank you very much. And breakdown that to vacation. I'm sorry.
Well, this isn't really a vacation. I'm actually doing work down here in Brazil.
Yeah.
So.
Maddog no tiene vacaciones. Maddog is not on vacation.
Y a todos, gracias a los organizadores, y también avisarles y darles esta noticia de que desde el EPI tenemos para todos, sin excepción, los asistentes, organizadores, todos los que se conectan a las diferentes sedes, a la sede de Colombia, de Perú, de Argentina, de Bolivia, de Chile, de todos los países, que tenemos un cupón de descuentos para ustedes, que el cual lo pueden visualizar en la página principal de Flisol. Solamente eso por mí. Alejandro, muchas gracias y seguimos adelante con todo lo que tenemos programado para el día de hoy.
Listo. I appreciate everything for all your efforts, and I appreciate and I say to Jon Maddog, thanks a lot for get this conference. And I know that it's very difficult to make that in that new reality. Y pues a todos los internautas, a todos los visores de Latinoamérica, les mandamos un saludo desde la región -2, UTC -2 a la UTC +5. Son muchos países: Brasil, Colombia, Uruguay, Venezuela, Argentina, Panamá, Cuba. Si se me salta alguno, le pido disculpas, Salvador. Entonces, a todos un saludo fraternal y que agradecemos a todos y vamos a seguir con el evento. Agradecemos a todos y sí, esto es una carrera contra el tiempo. Thanks a lot for everything.
You're welcome. Thank you. Adiós.
Sí.
Ay, bueno. ¿Estamos fuera? ¿Estamos
Listo.
dentro? ¿Dónde estamos?
Entonces, continuamos con la siguiente conferencia en este canal.
Sí, en Fish
Dame un momento.
¿Conectamos entonces, Alejandro?
Seguimos con nuestra conferencia de... Sí, en el canal Bash.
Ok, ¿nosotros qué hacemos? Vamos
Muchas
a tu
gracias a todos
conferencia, ¿no?
ustedes. Vamos a
Sí.
un corte mientras tanto.
Sí.
Listo, gracias.